and then I'm going to maximize here so you get a full screen view. There we go. And today, let's review a little bit. So the last time we talked, we spoke about integers, okay? And integers are positive, negative whole numbers, all right? And then we looked at actual applications. You know, like if you were standing at sea level, that's 0 feet. Above you would be positive, below you would be negative, all right? Then we looked at comparing numbers using inequality symbols. And the idea behind this was the larger number is always further to the right on a number line. So as long as you can remember that, it's easy to compare. Then we talked about the opposite of and that negative sign. And the one that we really have to be concerned with is right here. It's when you have two negatives back to back. Now, I need you to note the grouping symbol. The grouping symbol are parentheses, all right? So when you have two negatives back to back and the grouping symbol is a parenthesis, what you're really asking is what is the opposite of negative 5? What is the opposite of negative 5? And that's positive 5. So then we kind of just say, okay, well, if you see two negatives back to back and the grouping symbol is a parenthesis, just make it positive. Then we transitioned into absolute value, and we learned that that's a measure of distance. And because it's a measure of distance, the absolute value is always a positive value, okay? The only hard part was, or the tricky part about this, is right here with this example where you have a negative out front of the absolute value symbol and you have a negative inside the absolute value symbol. And you got to think of the absolute value as grouping symbols, and you got to do that first. So that is why I have, and I'm going to read it from left to right, letter D, the negative absolute value of negative 7, and then that transitions into negative 1 times times positive 7. So what we did is we evaluated the absolute value of negative 7, which is positive 7. And then that negative sign on the outside of the absolute value comes along for the ride. And we think of that as negative 1. So now it becomes negative 1 times 7, which is negative 7. Okay? Lastly, we just took everything that we learned and we started applying it to our order of operations. So remember, you do parentheses first, exponents second, multiplication and division are in the same line, so they have the same order of importance, okay? It's just you do them from left to right in the order that they appear. And then addition and subtraction, once again, same line, same, they're equal in terms of operation. You just do them left to right in the order in which they appear. Any questions? Okay, so today, I'm sorry, did somebody say something?
I was just saying no to, I have no question.
Okay. So thank you. So today we're going to look at section 2, which deals with adding integers. All right, and this honestly not going to take me long to explain. All right. So if we think about adding integers, now remember, integers are positive and negative whole numbers. All right, if I gave you a very simple example like this, 3 plus 5, okay, you know the answer is 8. On a number line, I can model this by saying, well, I'm starting at number 3, and I need to move to the right. That's the plus sign. I need to move to the right 5 units. So 1, 2, 3, 4, and 5. Okay? So that's how we get the number 8. All right? But I can also take the same idea and apply it to a problem that looks like this. Actually, let me write it like this, because you're going to see it like this in your book. All right? Now, this should look kind of familiar. And what I mean by that is, do we all see how we have two signs back to back? We all see that? Now remember, in the previous section, when we saw two negatives back to back, we automatically made it positive, okay? In this situation, I have a positive and a negative back to back. So what I'm going to do is I'm going to rewrite this as negative 3 minus 5. Does that make sense, everyone? Negative 3 minus 5. Are we all on the same page so far? Oh, sorry, I hit the wrong button here. You probably see my web browser, so I got to wait until it loads. There we go. Sorry about that. So on a number line, here's what's happening. Here, I'm starting at -3, okay? And then this minus sign right here in front of the 5 tells me move to the left. So I'm going to move to the left 5 units. 1, 2, 3, 4, 5. So -3 minus 5 is -8. Okay? Now, this method that I'm using right here is it's I think it's very effective. It kind of demonstrates physically what's happening, okay? But the problem with this is that eventually you get to problems like this. -25 minus 127, okay? And what I want us to avoid is drawing the number line and then trying to move 127 spots to the left. Like, it doesn't make sense to do that. Your number line would be massive. So I'm going to introduce a rule for us. All right, and here's our first rule. If the signs in front of the numbers are the same, and that's important, then add the numbers and keep the sign. And that's our rule. That's going to help us out tremendously. So real quick, we saw this example already. We know the answer is -5. I'm sorry, we know the answer is -8. But if you think about this, if I look at the 3, the sign in front is a negative. If I look at the 5, the sign in front is a negative. Therefore, the signs are the same. So what I'm going to do is I'm going to add the numbers. 3 plus 5 is 8. And I keep the sign. Since both of these were negative, I keep it. The answer is negative. Now, if we just follow that with the example I have above, -25 minus 127, since the signs of the numbers in front are both the same, what I'm going to do is I'm just going to add the numbers. So 7 and 5 is 12, carry the 1. 2 and 2 is 4, plus 1 more is 5. And 1 plus 0 is 1. So I know what I'm going to do is add the numbers, keep the sign. So -100 or -25 minus 127 equals -152. Okay? Are we all on the same page?
I am.
All right. Asma, how you doing? You good? You can just give me like a little nod or a thumbs up on camera. Perfect. Perfect. All right. So I'm going to give you a couple to do now. I promise I won't make them too crazy. All right. There's the first example. Here's your second example. And I'll give you one more. Try those 3. Okay, we good? So for the first one, what did we get?
I got negative 33.
Negative 33. I agree.
Same.
That's what I got too.
Perfect, perfect. What about the second one? What about 2 plus 10?
12.
Yeah, 12. Amber, that was so, you gave me so much enthusiasm with that 12. Thank you for that. And what about the last one? That negative 5 plus a negative 6?
Negative 11.
A negative 11. Awesome job, everybody. Perfect. Now, the only way that I can try to make, I guess, these problems a little bit more difficult is if I kind of just switch up the directions a little bit. For example, if I ask you to evaluate each expression, when x equals, we'll say, negative 3. And here are the expressions. X minus 3 and 100, we'll say 100 minus x. Okay? So remember, evaluate me. Oh, geez, oh man. Give me a sec here. I changed my desktop to all the Super Saiyans for Dragon Ball Z. Not that you care, but I figured I'd share that. Evaluate means to substitute. So, if you were like me and you were very strict and disciplined with how you do your math, watch how I do this. You got to do this. Directly underneath, wherever you see the variable, put parentheses first. Then make your substitution. Okay? So now for the first example, it's negative 3 minus 3, which is negative 6. Now, that second example, this is why you need to be careful. With part B, I'm going to rewrite the problem. Wherever I see the variable, I put parentheses. Then I make my substitution. Notice with part B, I got that double negative back to back, which means I'm going to rewrite this as 100 plus 3. And 100 plus 3 is 103. All right? So you gotta be very, very careful when you're doing this. All right? Because I don't want us to make a mistake or anything like that. Okay? Are there any questions? All right. So let's move on to the next section. So section 3 deals with, and sorry, I'm off screen because my keyboard's over here. Deals with subtracting integers. All right. So once again, I'm going to show us a very simple problem here. And if you compare this problem with all the previous ones, all the previous problems, the signs in front of the numbers were always the same. They were either both positive or both negative. Here's a situation where they're opposite. So I think a number line will do us good. So if I read this from left to right, it says negative 3 plus 4, which means I'm starting at negative 3. And that plus sign in front of the 4 tells me move to the right 4 spots. 1, 2, 3, 4. So negative 3 plus 4 is equal to positive 1. Okay? So for now, let's just take that for what it's worth. Let's do another one here. How about negative 10 plus 7? Well, I'm going to approach this the same exact way that I did the previous. I'm going to draw a number line. So if I read this from left to right, I'm starting at negative 10. And then I'm going to move to the right 7 units. 1, 2, 3, 4, 5, 6, 7. So the answer here is negative 3. So for me, when I look at this, I sit there and think to myself, well, there got to be a rule to do this. Because what happens when the numbers get large? All right, what happens when they get large? And there is a rule, and here's our second rule of the day. If the signs of the numbers are opposite, then, and this is going to sound a little weird, but let me show you how it works, okay? Then subtract the smaller absolute from the larger absolute. Then, all right, you know what? Let's put a period. Keep the sign from the larger absolute. So I'm going to give you a minute to write that down, and then I'll explain it. Because I know it's very wordy, but once you see it in action, it'll make a lot of sense. All right. So I'm going to scroll up here. I'll still have the row on the top of the screen. But I'm going to do that previous example again. Negative 10 plus 7. Okay? And once you get good at this, you're not going to do all these like little minute steps that I'm going to be writing out. I'm just going to show you how it works. So first thing I need to establish, are the signs opposite? Well, the 10 is negative, the 7 is positive, so yes, they are opposite. So here's what I'm going to do. According to this rule, it says subtract the smaller absolute from the larger absolute. So watch what I do here. I took the absolute value of both numbers. Now, I need to subtract the smaller from the larger. So if you look at the absolute values, 7 is small compared to 10, which is large. So I'm going to subtract 10 minus 7. In other words, the smaller from the larger. So 10 minus 7 is 3. So I know my answer so far is a 3. The question is, what's its sign? Well, according to the last statement, keep the sign from the larger absolute. So if I look at the larger absolute, since that sign was a negative, my answer is negative. And that's it. So it's a very wordy definition, but I think once you see it in action, it's a little bit easier. Now, this really helps us out. Excuse me. This really helps us out when the numbers are large. For example, if I look at negative 438 plus 591, I'm going to go ahead and apply my technique. I know the signs of the numbers are opposite. So I'll find the absolute value of each of them. $591 is definitely larger than 438. So I'm going to subtract the smaller from the larger. In other words, 591 minus 438. So here I'm going to have to borrow. That turns into an 11. That turns into an 8. 11 minus 8 is 3. 8 minus 3 is 5. 5 minus 4 is 1. Now I got to worry about the sign. Well, if you labeled correctly, notice that 591 was your larger absolute, and the sign in front of 591 is positive. So your answer is positive 153. Does that make sense? Are we all on the same page? Am I moving too fast? Are we okay? All right. So, excuse me. So I'm going to give you one to do. Let's see what you come up with, okay? How about 35 minus 79? All right, what'd you get? Amber, did you get an answer yet?
I got 44.
Positive or negative?
Positive.
Okay. Anybody else get something the same or different? Yeah, I'm thinking negative 44.
That's what I got too.
All right.
-44.
So let's do this real quick. We'll do it together. So off to the right, I'm going to find these absolutes real fast. All right, this is definitely larger. So I'm going to take 79 minus 35, and that gives me 44. But Amber, you got to be careful because remember that 79 had a negative in front of it from the start. So your answer is going to have a negative in front of it also. Does that make sense? Okay. Now, the only way that I can try to trip you up here is by trying to write the problem in a clever way. So what I mean by that is this. Here's two examples. All right, on the left side, we have 21 minus 13. Very straightforward. On the right-hand side, we have 21 plus negative 13. But if you just take your time, you take a deep breath, and if you read the problem, that plus and minus, we've seen that before, correct? So when you have a plus and minus back to back, what is it really? Remember,
Minus.
good, Todd, good. Remember, two negatives back to back are a positive, but a plus minus back to back is a negative. So you put a minus sign in between them. So although these two problems initially look different, they're actually the same problem. Now, what's nice about this, you can literally just stack this and just subtract. I got to borrow. 11 minus 3 is 8. So the answer is 8 for both of them. How are we looking? Are we okay? All right. So, like I said, the only way that I can make these more difficult is by giving you an evaluation problem. So I could say evaluate 20 minus z when z equals 12. Remember, always write down the problem underneath. Wherever you see the variable, put parentheses first. And then you're going to make your substitution. So this is really 20 minus 12. 20 minus 12. Okay? And 20 minus 12 is 8. I think we could do that one in our head. It's like having $20. You spend $12. You get $8 back in change. Another way I can kind of, I guess, try to trip you up is this. I can give you a word problem. The difference of 11 and negative 4. Well, remember, difference means subtraction. You got to have two numbers to subtract. So I'll put a subtraction symbol. The first number is 11, and the second number is negative 4. So here I have two negatives back to back, which actually turns out to be a positive. And 11 plus 4 is 15. How are we looking so far? Pretty good? So within these two sections, we learned two rules. The first rule, if the signs of the numbers are the same, add them, keep the sign. Rule number 2 was if the signs are opposites, you got to find which one's the larger by using absolute values and then subtract larger minus smaller and then keep the sign of whatever you deemed was the larger number. Okay? The last thing was be careful. All right? These two problems are not the same. And where you really need to focus on are the signs. Whenever you see two signs back to back, take a minute and rewrite the problem in its proper form. Okay? All right? I think the hardest part about this chapter is just slowing down. Just slowing down. All right? We're all, like I said, you're all very smart. You made it this far. Our brains they move so fast that we have to be able to start slowing ourselves down a little bit. All right? So now for the last section, because I don't think I'm going to be able to get 3-5, but we'll try. This section's super easy. Multiplying and dividing integers. All right? All you need to know is this one thing right here. Here's what you need to know. If your first number is positive and your second number is positive, if you're multiplying or dividing, it doesn't matter. Your answer is going to be positive. If your first number is positive and your second number is negative, the result will be negative. Doesn't matter if you're multiplying or dividing. This applies to both. If the first number is negative and your second number is positive, your result will be negative. And then the last one, if both numbers are negative, when you multiply or divide, the answer will be positive. Okay? It's as hard as it gets right there. And if you think about it, row number 2, row number 3, and row number 4, you've already seen that. Let me show you where. Oops, sorry. Let me write it like this. I'm losing it today. Notice right there you have a plus minus thing. Remember, we rewrote that as 4 minus 1. Well, how did we get that minus sign? Those two signs are actually being multiplied together. That's right here. A positive and a negative equals a negative. And then down here you have two negatives back to back. Two negatives make a positive. So you were kind of doing this little multiplying and dividing integer thing in the first two sections. It's just you were using it to rewrite problems. Okay? So now what I want us to do is just a bunch of examples. Because it's in terms of like learning something, this is it. This is your third rule. So here's some examples. -6 times 8. Let's do the easy part. Autumn, the easy part, what's a negative times a positive?
Negative.
Good. The hard part, you got to know what 6 times 8 is. That's 48. See, the easy part is the sign. The hard part, you got to know how to multiply. All right, let's try another one. -4 times -5. Well, the easy part. Negative times a negative is a
Positive.
perfect, Todd. What's 4 times 5?
20.
20.
Good. Todd and Autumn in stereo. I love it. Thank you for all the participation. All right, let's do another one here. Three times 20. The easy part, a positive times a positive is another positive. The hard part is you actually got to know how to multiply. 3 times 20. So the answer is 60. So, since we did some multiplication problems, let's do some division. -49 divided by 7. Well, a negative divided by a positive is a negative. So I know my answer is going to be negative. 49 divided by 7 is 7. Okay? The only hard part would be a problem like this. Let's do -225 divided by 3. All right? So, hopefully, you're starting to see like the pattern I do, which is, let's do the easy part. A negative divided by a positive is a negative. So I know my answer is negative. 225 divided by 3. I can't do that in my head. So I literally have to write that out. And I'm going to use long division. I'm not going to worry about the sign because I already did that. I already worried about the sign at the very start. So 3 goes into 22 7 times. That's going to be 21. 2 minus 1 is 1. Drop down to 5. 3 goes into 15 5 times. So -225 divided by 3 is -75. So the hard part here, you got to know how to divide. The signs are easy. When you're multiplying or dividing, signs are easy. Okay? Any questions so far? All right, I have a question for you now. Two examples. I want you to go ahead and simplify them for me. Tell me what you get. I'm going to go grab a drink of water. I lied. I got Turner's iced tea, the drink of the gods. And if you're from Allegheny County and you don't know about Turner's iced tea, then I have two things to say. Number one, shame on you. And number two, I'll buy you some because it is absolutely delicious. So here we go. What'd you get for the first one?
16.
Asthma. Excellent job. What did you get for the second one? I'm sorry, I didn't hear you.
16 again.
16 again? Geneva, what did you get? Because I think you said something different. And I agree with you. Oh, boy. Wait a minute. Something's happening here. Amber, would you agree something's happening here? As the kids say, this looks sus. Is that what the kids say? This looks sus. I don't have kids. I watch a lot of TikTok. I just recently learned, like, what this meant. You know, like, sheesh. I learned what that meant. I had to Google it. It's not that great, I guess. But anyways, something's happening here. And what we need to do is we need to figure out what's happening. So we need to go back and understand, what is an exponent? So remember, an exponent tells us to multiply the base that many times. So if I look at the very first example here, notice that -2 is contained inside the parentheses, which means I have to rewrite the quantity -2 exactly how it looks 4 times. So now let's do the hard part, let's do the easy part first. A negative times a negative is a positive, and a negative times a negative is a positive. So these are both going to be positive. And a positive times a positive is another positive. So I know the answer is going to be positive. Question is, what's 2 times 2 times 2? Times 2, I think I did 4 2s. I can't remember. Well, that's going to be 16. So I completely agree with that answer, 16. It's the second example that we got to be really careful about, okay? Now, there is this thing that we learned. The order of operations. Now, in this situation, there are no parentheses around that -2, okay? So what's really happening here is this problem, -2 to the 4th power, is really -1 times 2 to the 4th. And according to the order of operations, if there are no parentheses, you must do exponents next. So I'm going to rewrite this -1 times 2 to the 4th as -1 times 2 times 2 times 2 times 2. I need to do the exponent first. And 2 to the 4th is 16. And -1 times 16 is -16. And that's why those two problems are different. Okay? A long time ago, you may have heard your teacher say, well, in the first example, since the -2 is contained inside the parentheses, that entire thing is being raised to the 4th power, versus in the second example, only the 2 is being raised to the 4th. While I agree that is correct, I don't like the way that is said. Only the 2 is raised to the 4th, because then when I hear that, I instantly go, well, what about the negative? And then they never really answer the question fully. So you got to remember, if you have parentheses, you are going to rewrite that exactly how it looks with the parentheses. If there are no parentheses, your answer is going to be negative, because only the number is being raised to the exponent and not that -1 out front. That -1 is being multiplied. So here's another example. Okay? In the first, you have the quantity of negative 5 to the second. Listen to the way I even said that. The quantity of negative 5 to the second. Well, that means negative 5 times negative 5. Negative times a negative is a positive. 5 times 5 is 25. With the second part, that is negative 5 raised to the second power. And boy, I even hate the way I said that. Because it doesn't drive home the fact that this is really negative 1 times 5 to the second. And I need to do exponents first. So I have negative 1 times 25, which is negative 25. Does that make sense, everyone? This is by far the trickiest. All right, if you're going to make a mistake, it's right here. All right? My only word of advice, slow down, take your time. Okay? So, oh, go ahead. I'm sorry.
Mr. John, this is going to be up on Blackboard later, right?
Yes.
Okay, my phone's on 1%.
Oh, geez. Okay. Need a charger.
Yeah.
All right. Yeah, it'll be up.
Thank you.
You're welcome. Thank you for the question, by the way. So, the last thing we're going to do with the last couple minutes in class is really nothing new. I'm not teaching you anything new here. The directions are simple. Simplify 12 minus 3 times the quantity of 9 minus 12. So we're taking everything that we've learned. And we're going to apply the order of operations. Okay? So, do you see parentheses? Yes. You got to do the work inside. Now, 9 minus 12, remember, the signs are opposite. 9 is positive, 12 is negative. So you're going to have to do that absolute value and everything. But I think we might be able to do this one in our head. 9 minus 12 is going to be negative 3. Now that I am done with parentheses, I scratch it out. I do not see any exponents. Now I'm going to multiply or divide from left to right in the order they appear. So here I see negative 3 times negative 3. Notice I'm taking the sign in front of each. Negative 3 times negative 3, okay? And negative 3 times negative 3 is positive 9. And then 12 plus 9 is 21. Okay? Any questions? All right, let's do another one. We'll increase the difficulty a little bit. Eight times negative 9 divided by the quantity negative 2 to the third power. All right, so once again, I write my order of operations to the right. Now I worry about parentheses. Well, I got this set of parentheses here, but that's just one number. It's negative 9. I have this set of parentheses right here, but that's just one number. It's negative 2. So there's really no work inside parentheses. So I scratch it out. Now I got to worry about exponents. Now I definitely have that. So what I'm going to do, notice that is the quantity of negative 2 to the third power. So I write it out 3 times. Then let's just go left to right. Negative 2 times negative 2 is positive 4. And positive 4 times negative 2 is negative 8. So I rewrite everything exactly how it looks. And I replace the quantity of negative 2 to the third power with negative 8. Also note, I'm not rushing. I'm just taking my time. I'm talking out loud because I'm teaching, but if I were doing this problem, I'd still be talking out loud. Because I think you learn more when you talk out loud. So go ahead and be that weirdo that talks to themselves. It's fine. Okay? Exponents are done. Now we're going to go left to right. Multiplication and division in the order in which we see them. So I have to do this first. 8 times negative 9 is negative 72. Now I can go ahead and do this. Negative 72 divided by negative 8 is going to be positive 9. Because a negative divided by a negative is a positive. 72 divided by 8 is 9. How are we looking so far? Pretty good? All right, so you know what I do want to do? We're going to do the last section. It doesn't take long. It's one thing, and you already know how to do this. Connor, can you do me a favor? Can you unmute yourself for a second?
Sure.
I'm going to ask you a question here. You ready? Before I actually type in the name of the section.
Okay.
If I ask you to solve this problem for me, 3 times x equals 12. Could you guess what x is?
Because it's not showing what x equals.
Right, but if I'm asking you to guess, like, what number times 3 equals 12?
4.
So you already know the answer. All right? So the answer here is x equals 4. Let me show you how we do this now, okay? We have this thing called the division property of equality. Now, do you remember the addition property of equality? Remember that from chapter 2? Whatever you do to one side of the equation, you got to do to the other.
Mm-hmm.
It's the same thing here, Connor. Same thing. Just watch. If you have two things that are equal to each other, what this property says, so give me a second, let me write it out real quick. Because I want to use a different color. What this says is you're allowed to divide both sides by the equation by whatever number you want, except 0. You're not allowed to divide by 0. Okay? But this is what the division property of equality states. So, if I give you the problem, 3 times x equals 12, and I ask you to solve, well, you are going to do the opposite of multiplication. 3 times x, the opposite would be division. I don't know why it's doing that. Now, on the left-hand side, 3 over 3, well, that equals 1. It's like having 3 slices of a pizza, and they're all still there. So, on the left-hand side, you get x. And on the right-hand side, 12 divided by 3 is exactly what Connor said. 4. Does that make sense, everyone? The only way I can make this more difficult is by giving you a problem like this. I could put the variable on the other side, and now you have to apply your rules for integers. Negative 15 equals negative 3 times x. The opposite of times is division. So I'm going to divide both sides by negative 3 to give me x equals positive 5. Because a negative divided by a negative is a positive, and 15 divided by 3 is 5.